Timber HP by GoLab, we're going to be entering the market in 2022 with domestically produced wood fiber insulation made right in Madison, Maine. And our key tagline is insulate better, live better. So we're going to be producing 3 product lines, be a blown-in product, which would be similar to cellulose or loose fiberglass for attic applications and dense packing in cavities. We're going to have a press-fit bat product, which would be similar to the fiberglass and mineral wool bats that are on the market today. And we'll also have a continuous exterior board insulation. And we'll kind of dive into the products as they stand out of Europe and how we're going to be manufacturing them stateside here shortly. So when you look down this big list of bullets, I'm not going to dive into all of them, but the big thing to keep in mind is wood fiber insulation and dry process format's been around for over 2 decades in the European market. Today, it accounts for about $700 million in annual sales in the EU, and that's growing tremendously. And to think about wood fiber insulation, it's a complete above-grade thermal and acoustic solution, all made from one material, and it's the same exact material we use to frame and sheathe our buildings, wood. And really just that third bullet is what I want to highlight is windproof, waterproof, and breathable. When thinking about wood fiber insulation, that's really how you have to think about it. It's really the Gore-Tex of the insulation, and that's truly the definition of Gore-Tex: windproof, waterproof, and breathable or vapor open. So these are the huge players in the European market, and Will's representing Styco, and we also have a representative here who's representing Gutex. So we also have Pavatex and Schneider. So those are the large producers. Styco is the largest producer of wood fiber insulation in the world. There's 15 manufacturing facilities in Europe, and there are 4 more slated to come online over the next 2 to 3 years, which will actually bump up the annual sales of wood fiber insulation to close to $1 billion in the EU. Right now, everything has to get shipped, and Will can certainly talk about this too, shipped overseas to North America on containers. So when we enter the market, we're going to be very fortunate in the US that our wood costs are 1/3 of the wood costs in Europe, and our energy costs are half. So really today, wood fiber insulation in the European market is a premium, green, sustainable product that is focused on about 20 to 25% of the residential construction market, because that's pretty much all that's wood frame construction in Europe. Most of it's masonry. When you start looking at the US and Canada, 90% plus residential construction is wood frame. So we have a huge opportunity here. And with the price point, we're able to come in on par with a lot of the popular insulation materials that are on the market today. So loose fill will be priced per pound as the same as all borate cellulose. Our board product per board foot will be right in line with many of the foam products on the market. Our bat product will really be in the sweet spot between mineral wool and fiberglass. So anybody in the construction industry right now is really thinking, well, wood fluctuates tremendously in price. Wood is through the roof right now. So how are you going to be able to enter the market and have a stably priced product? Well, we're actually using the leftovers from lumber production, the residuals, and we're using low value fiber. And all that fiber has been destined for paper mills over the years. But just in the past 5 years, we've lost 6 paper mills in the state of Maine. And we've lost so many paper mills across all of the US. All that low value fiber needs a home. It needs value add to go into a product, into a composite that can be used in the market. And if you look at the Pacific Northwest has really very little use for that low value fiber. So they leave it in the forest, and that can cause a lot of issues with wildfires. In the state of Maine, we've been fortunate that we've been able to find some creative uses for wood fiber, but really at this point in time, we need somewhere to put low value softwood residuals. And that's really what our product's going to be made out of. It's going to be made out of spruce pine fir and maybe a little bit of hemlock too. And, really what our mission is at Timber HP is we're taking this proven technology from Europe and we're translating it for the North American market and showing the mainstream construction world how wood fiber insulation can be really the ultimate above grade solution. It can be a low risk drop-in replacement for the products that are on the market today, or it can be that comprehensive above grade full solution, looking at cavity, attic, and continuous exterior insulation. So for us entering the market, Timber HP, I'm from mainstream construction. That's my background. HP out of the gate means high performance, but we have so many stories to tell, and we look at our different layers of impact, healthy planet and healthy people, and we could talk about that more throughout our conversation today. So our blown-in product, softwood residuals, goes through a refining process. We mix it with borate, so boric acid in the wet phase, so that actually requires half as much boric acid as, say, a cellulose where it's introduced in a dry phase. And then that product is bagged, and it's just a loose fill, dense pack product. We've been doing R&D testing of European product, and we were able to come back with an R3.8 per inch. Due to the shape and size of the fiber, we have very little settling that takes place. We have a very fiber stream and feedstock, so we don't have any plastics being introduced. It's not recycled content. It's all fresh virgin fiber. We've done R&D testing, E84 flame spread. We came back with a Class A rating out of the gate with UL on this product. This same fiber goes into our bat product, and we mix it with a polyester fiber and then cook it in an oven, and we'll be producing these press fit bats. And this is really how it's produced in the European market too. This is the same exact fiber or process that they use to create mineral wool bats. Instead of using softwood fiber, they're using steel slag and basalt, but again, they're blending it with polyester fiber, baking it in an oven. Things to keep in mind: vapor open, R4 per inch, low thermal conductivity, so you don't have to worry about transferring that exterior heat to the inside of the structure. Large thermal mass, so it'll hold heat, radiate it back in to the building. And again, we tested this product with UL and came back with an E84 Class A flame spread. And just, I thought I might show a video. This is me taking a big torch to a small bat. I think for the mainstream world, and certainly for anybody who's in construction, you start talking about wood fiber insulation, you can't really start talking about performance or any other layers of virtue or merit until you start talking about water and fire. People have to know it's not going to burn. This is the bat product just treated with boric acid as a fire retardant, and you can see that the flame just gets extinguished. And again, vapor open, R4 per inch. The board product, out of the gate, we won't really introduce flame retardants. There'll be a little bit of boric acid introduced for mold and mildew inhibition and to deal with insects. We will have a Class A product that we will have a little bit more flame retardant in it, but without much flame retardant at all, this product out of Europe today will achieve a Class B flame spread. We've R&D tested several boards with ICC NTA and came back with Class B flame spreads. And these are all products with no flame retardants really in them. Things to keep in mind here is you've got great compressive strength. So when you're installing that bat and rain screen, you don't have to worry about the product getting squished, having to spend a day shimming your bat and rain screen because lack of compressive strength on your exterior continuous insulation. And the fact that it's vapor open, it's not going to trap that indoor humidity against your sheathing and your studs. It's going to allow that vapor to exit that assembly. You're getting drying to the inside of the structure, drying to the exterior of the structure also. This is a project, again, entering the mainstream market, 1.5-inch product, about an R3.7 per inch. So 1.5 inch will meet code compliant R5 continuous insulation, but a lot of the projects out on the market today are passive house or higher performing building envelopes. This is a project out on Bar Harbor, College of the Atlantic, where they use Gutex Multitherm, and you can just see the durability of this board product. These are just slabs of scrap that the construction crew used for months to go in and out of this building, and all the dimensional stability is there. Just the way that the product is made. It's a blend of softwood fiber, PMDI adhesive, and 1% paraffin. So this product is both vapor open and hydrophobic. So it repels bulk moisture. And in the European market, this board product is used so frequently in roof applications, and during construction, they'll allow you to leave it exposed for months before covering it, so it's able to take UV bulk moisture exposure. For us, we see the huge potential in the mainstream market for just sidewall applications and replacing a lot of those continuous insulations that trap moisture in the building envelope and also cause issues with installing your cladding and having issues with compressive strength. And this is, again, me just taking a torch to some of the foam options out there that wood fiber is looking to replace. So obviously EPS and, all these foam products actually have flame retardants introduced into them, but when they get exposed to flame, they melt. And, they off-gas some pretty nasty things. And we're going to work our way right down the line. So we did EPS, we're doing a couple XPS, and then we'll take the torch to a wood fiber box in just a moment. This wood fiber box is a European import without any flame retardant. And I'll just let the video kind of speak for itself.
Class B, right, Scott?
Class B. Right here, repelling the flame, that surface is carbonizing, and you can see what happens when I take the torch off. So though we'll enter the market with a Class B, we do have intentions of being able to offer a product with a Class A rating by adding a little bit of additional boric acid to the line, or some flame retardant. Again, it's used on the exterior of the structure primarily. So, I mean, we could probably use ammonium sulfate too. If it's going to be used on an interior application and a Class A is needed, we're going to stick with boric acid. We just don't want to run into any issues with some nasty off-gassing that obviously can be confronted with ammonium.
As well as potential corrosion issues sometimes.
Yeah, exactly right. So again, on performance, just the product, wood fiber insulation, vapor open. The board product does a great job managing moisture. Again, vapor open, but also being hydrophobic. If it does, for some reason, become saturated, maybe there's a poor flashing detail around a window, bulk moisture enters the board product. Through capillary action, that moisture will spread out through the entire surface, and it'll exit that product when conditions allow. It can hold up to 15% of its weight in moisture without losing any R value performance. And again, insulation for all seasons. I mean, the product has low thermal conductivity. It's not going to transfer that heat from the exterior environment to the inside. Significant lag time. It's got great heat capacity. It'll hold that heat, radiate it back out. The same goes for thermal capacity when we're heating our structures in the fall and winter. It's going to hold that heat and radiate it back into the structure, just like a log home. And again, when it comes to healthy people, you got to think about, we're creating these vapor open assemblies, so we're really focused on indoor air quality, but also just think about the folks who are using these products, not having to worry about what you wear home at the end of the day after you've been on the job site. These fibers aren't going to be embedded in your skin. You're not going to wear your insulation for a week after an install. You don't really have to worry about what you're breathing in because it's over 90% wood. Again, just focused on healthy people also. And, acoustically thinking about all these safe indoor habitats that we're creating these days, certainly spending more time inside during COVID and just wanting to keep the chaos of the outside world out and maybe the chaos of the kids in the next room away. Thermally, great performing product, acoustically, amazingly performing also. And on Healthy Planet, I mean, you start thinking about insulating with wood fiber insulation, the product is renewable, sustainable, recyclable. All of our scraps can go back into our production. We could take scraps back from the job site, throw them back into production. And, carbon sequestering. We try to drive down the operational carbon in the built environment by using all of these products that are so dependent or completely derived from fossil fuels. So, I mean, it's kind of counterintuitive. We're trying to address global climate change today, but we're putting products into the built environment that it takes 8 to 10 years to offset their carbon footprint with operational savings. Wood fiber insulation arrives at the job site already carbon negative out of the gate. The savings on carbon are immediate. You know, the whole idea behind carbon sequestration is we're trapping more carbon into this built environment, far more than what it takes to produce this product line. So really,